Hi everyone, today we're going to cover exponential equations and some logarithmic equations. So let's get started. The first thing we're going to do is a short warm-up. Using properties of logs to write a sum or difference of similar logs. We did this on the last lesson, so what we're going to do is expand that. And in order to expand that, we're going to remember that for our log properties, and that multiplication, these two are multiplied, means addition, and these are multiplication, so that's going to be addition. And this line right here is representing subtraction. The division is subtraction. So I'm going to first separate these. So I'm going to separate the numerator from the denominator, and then in doing that, I'm going to separate this times in here into 2 plus equations. So remember that the log base b is all going to have the same base, so you're not going to be changing that. So we have log base b of this value, which is the square root of x, plus log base b of y to the 4th power. And then this division is our minus. So now we have another part, which is going to be log base b of z to the 4th power plus, because of the times in here, these two are times, using a product rule, you're going to have log base b of the cube root of u squared. So using this, what we're going to do now is we're going to use the power rule, because this square root of x right here, the square root of x, that's the same thing as saying x to the 1/2 power. And remember that if this was x to the 1/2 power, I would need to take this 1/2 and bring it to the front, according to the power rule. So that would actually be 1/2 log base b of x plus, same thing with the 4. The 4 will be brought to the front, plus 4 log base b of y. We're going to distribute this minus sign to both of these terms here. So it's going to be minus, for this one, it'll be 4, because this 4 here is going to go out front also. So we have 4 log base b of z, and then minus, because remember the minus, and a lot of people forget this minus goes to this quantity and that quantity. And so that'll be minus, and then I'm going to rewrite this right here. The cube root of u squared is actually rewritten as u to the 2/3 power. And remember, if that's an exponent, when I rewrite that, that's going to move to the front. So that'll be minus 2/3 log base 6 of u. Okay, that's it. We're done. You expanded it, and that's all you had to do. So you just box this whole thing up. On this problem right here, they're asking you to take this equation, and instead of expand it, they want you to condense it, basically. And so we're going to rewrite that like this problem here on the top. So this one, we're going to start off. Minus means, this minus sign right here means divide, and so does this. But I noticed that there's 2 minuses. So I'm going to distribute, I'm going to take one out. And while I'm doing that, I'll show you what I'm doing. So basically, you're going to say log base a of x squared minus 1, and that's this quantity to the 1/3 power. That's this 1/3 coming back up here. And I'm going to minus or subtract this log base a of y plus, and the 4 is going to come up here, plus log base a of z to the 12th power. So see this minus sign, what that's doing is going to be a division. This plus is going to be a times. So what that's going to ultimately give me is one term, and it's going to be log base a, and my term is going to be this on the top. And I actually can rewrite that as the cube root of x squared minus 1. Now on the denominator, there's your minus sign. That's your division right there. I'm going to combine those, and plus means add. So that means, plus the plus is times, and that's going to mean the value of y times this value, which is z to the 12th power. And that's it. So you would just box that up, and now we've condensed it. So what we're going to practice right now is basically trying to simplify the following exponential expressions. This is going towards solving exponential equations, but first we're going to practice just reducing. So we have 64 to the 3/2 power. My recommendation is always try to reduce the problems as much as you can. It's not necessary every time, but I do recommend that you do that because it just makes it easier in the long run. Sometimes, some you can reduce more quickly than others. So 64, if you broke 64 down, another way of writing that is 2 to the 6th power. And that's just this right here. It is to the 3/2 power. So you're going to be multiplying by the 3/2 up on the exponent in the power area. You're going to reduce. Your 2 is going to divide into the 6 3 times, and you have 3 times 3. And so therefore, that's going to be 2 to the 9th power. Okay, so a couple of other things that I did want to stress, and then that's your answer. Of course, you can simplify 2 to the 9th power. But there is another way of doing that. And that 64, of course, is rewritten as 8 squared. And of course, you have the 3 to the 2nd power. The 2's are going to cancel, and you get 8 to the 3rd power. This value, 8 to the 3rd power, should be the same value as your 2 to the 9th power. And so 8 times 8 being 64 times 8 is 512. And this value here is 512. And so is this value right here. I do want to stress something, and that also is the fact that none of these are equations. And you notice that these arrows here, that's like go here, go here, go here next, go here next. Arrows are not equal signs. You cannot add in an equal sign on any of these problems because there are no equal signs. So don't start adding the equal signs. Okay, this problem right here, let's make 1 over 25. Let's make that 1 over 5 squared. And that's still to the negative 3/2 power. Okay, what I'm going to do at this point is I'm going to take this 5 squared and bring it up. And in doing so, that becomes 5 to the negative 2 power. And then you have negative 3/2 there, already there. And so what's going to happen is these 2's are going to cancel and make 1. The negative is going to cancel and make positive. And so I'm going to have 3 times 1. So I'm going to have 5 to the 3rd power, which is equivalent or the same thing as saying 5 times 5 times 5, which is 125. Okay, this problem right here is saying the opposite. So that value right there is saying the opposite of 27 to the 2/3. And this one is saying 27 to the 2/3 power. So when you're working these out, this value here is the opposite. 27 is, we're going to rewrite that as 3 to the 3rd power to the 2/3 power. 3's are going to cancel. I'm going to get the opposite of 3 squared, which is the opposite of 9. And that's my answer. Whereas this problem is just 3 to the 3rd power to the 2/3, and 3's will cancel, make 1, you get 3 squared, and that's 9. For these problems, evaluate without a calculator. For this problem right here, this is actually a little bit raised up. Doesn't look like that, but it should be up a little bit more. This should be 81 breaks down to 9 times 9, and 9 times 9 breaks down to 3 times 3, and then again another 3 times 3. So basically it should be 3 to the 4th power to the negative 3/4 power. So this is over 1. So this is actually 4 cancels and makes 1. We get 3 to the negative 3rd power. Well, what that does, this negative exponent, see the 1 under here? What that does is it brings the value to the denominator. So now it should be 1 because this is the one out in front that we don't see, but we know is there. Okay, so that brings that as 1 over 3 to the positive third power, and 3 to the positive third power is going to be 1 over 3 times 3 times 3, which is 27. For this problem, this next problem right here, 4 ninths to the negative 3 halves, I always, like I said, I always recommend that you reduce these as much as possible. And the 4 ninths, I would say, is going to be 2 squared over 3 squared. And remember, both of those are still to the negative 3 halves power. That can be, see, this negative 3 halves needs to be multiplied by both of these exponents. So really, you have 2 to the second times negative 3 halves, and then you have that over 3 to the second power times negative 3 halves. And so with this problem right here, of course, the 2's will cancel and make 1. And what I have is 2 to the negative third power over 2's will cancel. And and that makes 1. So I have 3 to the negative third power, which then becomes, and of course the negative exponents change the numerator to the denominator and the denominator to the numerator. This will come down to the denominator and make it positive. So it'll be 2 to the third power. This will come up and become 3 to the positive third power. And your final answer is 3 times 3 times 3, which is 27, to 2 times 2 times 2, which is 8, and then you would just leave your answer like that. This problem right here is a little bit tricky. Everybody gets a little bit confused when they see a negative inside the parentheses, and you see on the denominator you see a cube, but you also see a square also. So I always like to point out that this right here, remember when you would say like x to the 1/2 power? Well, that's the same thing as saying the square root of x. And 1/2, there's the 1 here and the 2 inside here, the 2 being my denominator. Same thing with this. That 3, the 2 is not my denominator, that's my root. And the 3 being my root. So basically what this is saying is that you're finding the cube root of this value, negative 125 over 8, squared, that value here too. And anything squared here is going to be positive. And if you're taking the cube root of something that's positive, you're still going to get a positive value. So therefore, in this case, it's really not relevant. We don't need to use the negative sign because we know that when we square it with this number here, it will come out to be positive. So that's one way to think of it. Of course, working the problem out, same thing, but let's start and say 125 can be rewritten as negative 5 to the third power. And that right there is divided by 8, which is 2 to the third power. And all of that is to the 2/3 power. And then what's going to happen is these 2/3 are going to be distributed. So I'm going to have negative 5 to the third power to the 2/3 power over 2 to the third power to the 2/3 power. And what's going to happen with this is my 3's are going to cancel and make 1. And I'm still going to have, I'm going to come over here. I'm still going to have negative 5. This is what I'm having. Negative 5 squared over, and these 3's cancel, make 1, and I get 2 squared. Well, negative 5 squared is actually 25 over 4, and these are positive. So I still get a positive answer, but in the doing, it takes a little bit of stress off right here, knowing that there's no negative, because when you square the negative, it is positive. Now, these are what we call exponential equations. Exponential equations are when we have our x, our variable, in the power position. It's raised up. That makes it an exponential equation. But just know that if I have 3 to the third power is equal to, 17x, this is not an exponential equation. That exponent is a 3. So it's not really it's not a variable. So therefore, this cannot be an exponential equation. So just keep in mind the difference between what is an exponential equation and what isn't. For this problem right here, I do recommend that you always try to get your bases at the same value if possible. So we know that this is 2 to the 5x power. And 64 can be rewritten, again, 8 times 8. 8 becomes 2 times 4, which is 2 times 2 times 2. And then double that again. So you actually have 2 to the 6th power. Well, if your bases are the same, you can definitely set your exponents equal to each other. And then you're going to divide out that, and you're going to get x equals 6/5. I do want to remind you that we were working with logarithms prior, in that if I wanted to do this another way with a calculator, see here, I didn't need to do it because I didn't need a calculator. But if I had one available and I wanted to use that, I could do this another way, and that would be using logarithms. 2 to the 5x equals 64. This 5x comes out front, and you would get 5x log 2 is equal to log 64. 5x is equal to log 64 divided by log 2. And you can guess what this is going to be, of course, because if we're dividing by 5. A couple of things to remember. The logs, the word log, they can never be reduced. You can't just cancel those out. And also, 2 does not go into 64. That's not how that works. What happens is this here is a quantity divided by a quantity. And you can't break into that. So don't do that. So that becomes 5x is equal to 6. And x is equal to 6/5. Same answer, different way that I did that. This problem right here, see, a couple of things. See how this is written 1 divided by 8 like that? I would recommend that you stop writing your equations like that, or your fractions like that, and start writing them like that, because that's going to just make everything a little bit easier when we multiply. All right, so for this problem, I'm going to try to get my bases the same again. So this is 16. I'm going to break that down to a 2. So that's going to be 2 to the 4th power with the x. Now, keep in mind, when you are reducing this 16, for example, there's an x still up here. That stays there. Even if you reduce this, and you change it, rewrite it 2 to the 4th power, you don't lose this x. That stays there. Okay, and then 1/8. So let's remind ourselves, 1/8, that's the same thing as saying 1/2 to the 3rd power. So really, this right here, we're going to rewrite that as 1/2 to the 3rd power. And all of that is to the x minus 3rd power, x minus 3. See, that's going to stay up there. Now, in order to set the exponents equal to each other, you actually have to have the bases the same. So right now, you have one of your fractions is low, and you've got your base up here 2 to the 4x is high. So you need to take this 2 to the 3rd power and bring it up. The act of doing that, okay, bring it up. That's your changing that exponential power, its inverse. So you have 2 to the 4x is equal to 2 to the negative 3rd power. Don't forget the x minus 3. That's still up there. If the bases are the same, you can set your exponents equal to each other. So now you have 4x is equal to, and I'm going to distribute this negative 3. So I get negative 3x and then plus 9. This negative 3x, you're going to bring it over to the other side. So we're going to have 7x is equal to 9. So x is equal to 9/7. Again, just so you know, if you chose to do this by logarithms, completely fine. You'd have x log 16, right? Bring this out front, is equal to parenthesis x minus 3 log 1/8. And then you would divide so that your logs would be on the same side and your variables would be on the same side. So you would have x over x minus 3 is equal to log 1 over 8 divided by log of 16. And then, of course, you would cross multiply and divide. Okay. Next problem, solving exponential equations, another problem like this, except for in this problem, actually, we can leave our bases at 4. You don't have to change them to 2 because I know 4 and 4, I can get a 4 out of this, meaning this can be 4 to the x power, and this would be 4 squared to the this power, which is the x plus 10 power. Now my bases are the same, and therefore I can just set my exponents equal to each other. So I have x equals 2x plus 20, subtract x, or excuse me, just move this over there. I guess I'll subtract 2x, and I get negative x is equal to 20, so x is equal to negative 20. And that's my answer. And I would always suggest that you, especially if you have a calculator, you have use of a calculator, even a 4-function calculator, just plug your values in if you can to check your answer. I just do want to show you how to do this with breaking it down to 2's. So this would be 2 to the 2x, right? The 4 would be 2 squared, and then the x would still be here, is equal to, let's see, 16 is actually 2 to the 4th power, but you still have the x plus 10 here. Bases are the same. 2x equals 4x plus 40. I'm going to subtract, on this one, I'm going to subtract 4x. So I'm going to get negative 2x is equal to 40. I'm going to divide by negative 2, and then I'm going to get x equals negative 20 again. Okay. And lastly, of course, you don't have to do these problems 3 times, but I am giving you options in how to solve these, whether or not you have a calculator, etc. So if I did have a calculator, what I would do then is I might consider logging this if I didn't get the common bases. So I would go x log 4 is equal to quantity x plus 10 log 16. And then you would divide out the x plus 10s on both sides. Okay. And I would get x divided by x plus 10. And then on this side, I would actually be dividing by log of 4. Okay. And then on the right side, I would have log 16 divided by log of 4. And then I would just start cross multiplying. Okay. And my guess is that this becomes negative 2. And then that means I'm going to be multiplying those across. Okay. Solving exponential equations that have the common basis. All of these problems can be solved without a calculator. So if you want to pause the video and try working these problems out yourself and then checking your answer, that would be completely fine. Keep in mind, for this first problem, you cannot get the bases the same. The bases are not the same. So what that means is for this problem, I would not be able to get 4s. So I would reduce this to 2 squared, and then there's a 3x already up there, is equal to 8, which is 2 to the 3rd power to the x plus 1. Bases are the same. I'm going to get 6x is equal to 3x plus 3. And subtract 3x, I get 3x equals 3. And so x is equal to 1. For this problem, I'm going to reduce with 3s. So I'm going to have 3 to the 3rd power to the x minus 1 is equal to 3 to the 4th power, that's your 81, times 2x minus 5. Bases are the same. I can set my exponents equal to each other. I'm going to distribute. I get 3x, that's a 1, minus 3 is equal to 8x minus 20. And I'm going to subtract 3. I'm going to get 5x here. I'm going to add 20. I'm going to get 17. I get x is equal to 17 divided by 5. Box that up. Okay, now these two problems on the bottom, when working these out, we're going to use our change of base formula, which says base here, this base 3 across equal sign. So we're going to have 3 to the second power is equal to 4x minus 7. And then we're having 9 is equal to 4x minus 7. We get 4x is equal to 16. X is equal to 4. Please keep in mind that your argument, which is this value right here, can never be negative. And so make sure that whatever value you get, that you plug it back in here, and make sure it doesn't come out negative. So 4 times 4 is 16. 16 minus 7 is 9. So definitely not a negative number. This problem right here, I'm trying to make it a little bit bigger. This problem, again, we're going to use the change of base, especially since my base is an x. So we're going to go x to the second power, base to across the equal sign is equal to 64. Now this is not an exponential problem where these two up here were exponential equations because your variable was x and it was in the power. And so what's going to happen here is this is just an equation. Now, I know most people are going to look at that and say, well, I'm going to square root both sides, and that's now going to be 8. Well, I do want to offer another option. And just to remember that if you have x to the 1/2, right, when you're square rooting something like you want to square root this, you're really taking x to the 1/2 power. So what I want to do is I want to say this, x squared, and I'm going to rewrite 64, and I want to make that 2 to the 6th power. And this is just another option. I think this is a good idea to know that this is going to be, if I want to undo this squared, I'm going to take a 1/2 power of that, and a 1/2 of that is a square root. And I'm going to take a 1/2 of that also, because of course, this being an equation, if you take a square root of one side or a 1/2 power of one side, you have to do exactly the same thing on the other. So we end up getting x equals 2 divides into 6, 3 times 2 to the 3rd power is 8, x equals 8. Okay. Now this problem, I like to do this problem, and we call this the problem based on brute force. So what you're thinking is you're trying to guess what x is going to be, but you have a calculator to use to try to guess what it would be. So meaning, you know that 3 to the 1 power is 3, and you know that 3 to the 2nd power is 9, still not 20. You know that 3 to the 3rd power is 27, too much. So therefore, my answer for x, if I were guessing, is going to be in between 2 and 3, right? It's closer to 3 because it's a 27 as opposed to a 9. So what I suggest to my students is to have them start plugging in values. Plug in values and that's not right. I would start having you plug in values. And when the values that you plug in, 3 to the, let's say, 2.2, 3 to the 2.6, 3 to the 2.7, plug in values, and your job is to try to get to 20 without going over. And what I mean by that is I want something that's going to be like 19.9999, and I want that number. So in order to find that number, you're going to have to randomly plug in values. Okay, so if you want to take a minute to go ahead and practice that, then I would suggest you do that. So I hope you found out the number. The number ends up, once you try this, is about 2.7268. Well, I don't know if you guessed that or not, but it must have taken quite a while to use brute force in order to do that. Well, what we do is, if you haven't guessed already, is we log it. And basically, remember, the inverse of an exponential equation is a logarithm. And so you're going to have x log 3 is equal to log 20, which is the same thing as x equals log of 20 divided by log of 3. And again, when you do these problems, these little squiggly lines here, those mean approximation. That means approximate, okay? Because we're approximately trying to find the answer. We're going to be cutting off these decimals when we write our number out. And so with a calculator, 268, you would divide log of 20 and log base 10, right? You see a little 10 there that you know is there, but you know it's there, but you don't see it. So you have log base 10 of 20, log base 10 of 3, and you're dividing both of those quantities, and you end up getting this value right here. So let's clear that screen so that we can do that ourselves. So when we're doing this problem right here, again, this is also an exponential equation because my variable is my power. So it's up in my exponential power place. So we need to get that out of there. So we're going to move this out front. Now, you need to keep in mind, when we were working this problem out and solving for x, this exponential equation, bringing it out front, we took the log of that because the inverse of exponents are logarithms. Well, likewise, ask yourself, what's the inverse of e to the x power? Well, that's ln of x, or natural log. So basically, when I bring this out front, I do get 0.08t ln of e is equal to ln of 2500. Now, most people don't actually have to write this little step right here because ln of e is 1. And therefore, what that does is you can go from this equation right here just to 0.08t is equal to ln of 2500. Now, you do actually need a calculator for this problem. T is equal to ln of 2500 divided by 0.08, because both sides were dividing by 0.08. And when you work that out, that approximates to be, I think it's 97.8, something like that, 97.8. Okay? You can use your calculator on that and try to figure out what that is. That's something you definitely should know how to do. For this problem, the first thing you're going to do is move this over. You're going to try to move everything over until it's by itself. So we're going to now have 2e to the 3x plus 5 is equal to 14. I'm going to divide by 2 and eliminate this. So now I'm going to divide by 2. I get e to the 3x plus 5 is equal to 7. And this now looks very similar to the problem that we just did. We're going to bring this out front. We get 3x plus 5 ln of e, which is 1, is equal to ln of 7. And that's not an easy number. That's just what it is. We're going to subtract 5. So now we have 3x is equal to ln of 7 minus 5. Now, you're going to want to work that out on your calculator, unless you're not allowed to use a calculator, in which case your final answer would just be ln of 7 minus 5 and then divided by 3. But if you are allowed to use a calculator on whatever this assessment is, then you would just leave it, then you would work it out. Make sure that you work out the numerator first before you divide. For this problem, though, these are now all, this is an exponential equation. You cannot get the bases equal. So what's going to happen is you're going to log both sides. Now, you can log or you can take the natural log. Either one is fine. And what I mean is when I log, I'm going to get x plus 1 log 3. I'm pulling this out front. Is equal to, bring that out front, also x log 4. Now, when I'm doing this, I am equally okay to do this. X plus 1 ln of 3 equals x ln of 4. You're going to get the same answer when it's all said and done using either or. I'm going to get my x's on the same side. So on this, I'm going to divide by x on both sides. So now I have x plus 1 log of 3, base 10, of course, of x, or over x equals, x's cancel, log 4. And then what I'm going to do for this problem is I'm going to divide by log 3. So I have x plus 1 over x is equal to log base 10 of 4 divided by log base 10 of 3. And I'm just going to divide those out, divide by log 3. Okay, and then what's going to happen is I need to reduce that and with my calculator, and then I'm going to cross multiply. So meaning, I'm going to just work this out. I need to work that out. Let me see. I don't have a calculator with me, so I'm going to use my cell phone real quick. I'm going to say log of 4. So on this, I'm going to go 4 log, wherever that is, let's see here. And I'm going to divide that by 3 log and get an answer of 1.26. If I do that right on my phone, I'm going to get x plus 1 divided by x is about 1.26. So we'll say 1.26. And then you're going to cross multiply. You're going to go 1.26x is equal to x plus 1. I'm going to subtract x. I'm going to get 0.26x is equal to 1. I'm going to divide. I'm going to go 1 divided by 0.26, and I'm going to get 3.85. So x equals 1 divided by 0.26, which is about 3.85. Now, I do want to stress that I got this answer. I think I got the right answer because I don't have a calculator. Something could have gone right here. However, I absolutely can double check if I plug my answer back up here in there. Meaning if I go 3 to the 3.85 plus 1, I should get 4 to the 3.85, whatever that is. These should be equal. So you definitely can check your answer on these problems, and I would if I had a calculator. So we're going to talk about not exponential equations, but logarithmic equations. So there's this problem right here, and a lot of kids will look at this, a lot of students will look at this and say, what do I do? I don't know what to do. And I always tell my students to ask themselves, well, what's the base? What's the base? And in this problem, the base is 10. And then a lot of times when they put that value in, then they get, oh, I can do this, 10 to the second power. So sometimes that does help, 4x minus 3, base to cross the equal sign. We have 100 is equal to 4x minus 3, add 3. We get 4x equals 103. X equals 103 divided by 4. Okay. For this problem, you might want to remember that ln of x is the same thing as saying log base e of x. And in this case, if I replace ln with log base e, so we're going to go log base e of 2x minus 5 is equal to 6, then I can rewrite this and go base to a cross equal sign. So e to the 6th power equals 2x minus 5. I'm going to move the 5 over. I get 2x is equal to e to the 6th power, add 5. Now, keep in mind that e to the 6th power is just e. Remember, e is approximately 2.718. So that's just saying 2.718 to the 6th power. So that's something that you can do very easily on your calculator. So then you have x equals e to the 6th power plus 5, and that's divided by 2. And if you don't have your calculator, this is your answer. If you do have a calculator, you can estimate that. For this problem, one thing to do is, okay, so we know the bases are the same. We know the bases are both 10. When the bases are the same, that's the same thing as our log properties. See the plus? That's going to be times. We're going to use the product rule and combine these two terms. So we end up getting log base 10 of x times x plus 3 equals 1. And then you're going to say, oh, base to a cross equal sign. So you're going to go 10 to the 1 power is equal to the argument, which is x times x plus 3. So you have 10 is equal to x squared plus 3x. Now in this problem, this became an exponential equation. And what the first thing that you should remember about when you see an exponential equation is that you need to set it equal to 0. And so we're going to say 0 equals x squared plus 3x minus 10. And so in doing that, we're going to, I'm going to factor. Of course, you could use the quadratic formula if you wanted to, but I'm just going to factor. And so I get x, let's see, plus 5. 5 times 2 is 10. So x plus 5, and then x minus 2, because I need to multiply to be a negative 10, but the numbers have to add up to be 3. I'm going to split these up. I get x minus 2 equals 0. So x is equal to 2. I get x plus 5 equals 0. X is equal to negative 5. So I have two answers, but something that you need to remember is that your argument can never be negative. And so where is my argument? There's my base. Here's my argument. Here's my answer. B is my base. That has to be positive. Can't be negative. A is my argument. Got to be positive. Okay? Can never be negative. So if I were to plug in negative 5 in here, it's going to be negative. And you can't use it, can't be that. Now keep in mind, I also would plug it in here. Negative 5 add 3 is negative 2. That's still negative. So negative 5 is definitely not going to work. So now you have x is equal to 2. And you can look at it and go 2 plus 3, that's 5. That works. And then you're done. So that's the end of learning part 1. This is actually part 1. I have a second part that I will be posting tomorrow that is exponential equations and logarithmic equations part 2. And we're also going to throw in some exponential growth and decay, and also some learning on the TI Inspire. So I hope this helped, and I'll see you next time. Thank you.